Okay, welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 6 from the Cambridge 9709 paper 4 mechanics specimen paper. This question here is about variable acceleration and kinematics. The particle P, or a particle P, moves in a straight line. The velocity v meters per second at time t seconds is given by v equals 5t brackets t minus 2 for 0 to 4 seconds, and then v equals k from 4 to 14 seconds, and v equals 68 minus 2t for 14 to 20 seconds. So this object, it moves in different ways. Its velocity follows different patterns in different times, different domains of its time. So it says where k is a constant, we've got to first find the value of k for 1 mark. So k is basically the velocity, okay, in the region between 4 and 14 seconds. So it's starting off, okay, following this pattern here, 5t times t minus 2, okay, for the first 4 seconds. So when it reaches 4 seconds, okay, we can find its velocity at that point using this first equation. So when t equals 4, we can say v equals 5 times 4 times 4 minus 2, which is 20, times 2, which is 40. So that's the value of k, 40 meters per second, which is v is 40. All right, so v is 40. So we worked out v is 40, and now we're going to go to part B, which says sketch the velocity time graph for this between 0 and 20 seconds. So here's the relevant information just in sight. We can take this as 40 now. So we have to sketch the velocity time graph from 0 to 20 seconds on this. So what we'll do here is we'll put velocity against time. So we'll have velocity on the y-axis, and we'll have time on the x-axis. Just a bit of space to write better. So we're going to have velocity against time. Okay, so what's going to happen here is in the first part of its journey, between 0 and 4 seconds, it follows this quadratic type of shape. Okay, so we can try to figure out what is going to happen to it. This is a quadratic type of shape. It's like a smiley face. We can think of it as a smiley face. And if we just draw it normally, we can see that it's going to cross the t-axis, okay, when v equals 0, okay, and that's going to be when if 5t times t minus 2 equals 0, we can say that's t equals 0, and when t equals 2. So it's going to basically start from here. It's going to be on the negative side, so you're going to have a negative velocity. So I'll carry this down here. It's going to go down to minus 2, and then it's going to come up to 2. So let me put 2 over here. It's going to go down negative velocity, and then it's going to become positive velocity until it reaches, as we said, at 4 seconds, 40. So at 4 seconds, it's going to reach 40. Let me put 40 up here. So it's going to go down like this and up. So it's going to have this type of shape. It's going to go down and then up. It's going to reach 40. Okay, something like that. And then at 40 seconds, it's going to be horizontal. So this is 4 seconds here. Until 14 seconds, it's going to be like a horizontal line going at 40. Let me just keep this the same. So it's going to go something like this. From 4 to 14 seconds, it's going to be just a straight horizontal line, constant speed or constant velocity of 40 meters per second. And then for the last 6 seconds until 20 seconds, okay, for the last 6 seconds so until 20 seconds, you're going to have something which looks like this. It'll have a negative gradient, a straight line going from here down to 0. Okay, hold on, is it going to go down to 0? Let's find out. We're not sure yet. Let's find out. Let's see. When t equals 20, when t equals 20, you're going to have v equals 68 minus 2 times 20. So no, it's not going to go down to 0. V is going to be 68 minus 40, which is 28. So it's going to go down to about 28 meters per second. So we're going to go down to 0 at all. So it's going to go down to somewhere over here. So that distance here, that's 20. That's 4. That's 14. It's going to be something like this. Okay, so that's how the graph will look. 20 seconds, 68 minus 40. 68 minus 40, which is 28. Yeah. Okay, so there's your velocity against your time. So that's velocity per second, meters per second, and that's time in seconds. All right, so there we have the velocity time graph from 0 to 20 of this journey. Now then it says find the set of values of t for which the acceleration of p is positive. So the acceleration of p is positive from this point onwards, okay, until 4 seconds. Here the acceleration is 0 because it's gradient 0. Remember, the gradient of the velocity time graph tells us the acceleration. Okay, the gradient of the velocity time graph tells us the acceleration. So we can see here that the gradient is negative until it reaches this point here, its turning point. Okay, so it's going to be from this point onwards. It's going to be from this point onwards. Okay, until this point here. Okay, so it's going to be between these values of t. All right, so we can see that that's going to be where the vertex of this graph is, which is obviously going to be at 1. Okay, this is 0, this is 1. It's halfway between these two. It's going to be the vertex. It's a quadratic. So it's halfway between the two roots here. That will be the vertex because it's symmetrical. So we can see it's going to be between 1 and 4. Okay, so at the point it's at 1 itself, it will be 0. So I'll say greater than 1. The point it's at 4, it's reached this constant speed of 40, so I'll put less than 4. So t is between 1 and 4. Okay, we could also take the equation of the graph v equals 5t times t minus 5, and we could work it out that way. We could say v equals 5t times t minus 2, and we could expand it, so you get 5t squared minus 10t, and we could find dv dt, which is the acceleration, which is 10t minus 10, and we can find where is the acceleration 0. We can see it's going to be at 1. We can say, so 10t minus 10 is equal to 0, so 10t is equal to 10, therefore t equals 1. That's where the acceleration is 0. That's the minimum point here. Okay, but you can see visually even from the graph that these 2 points are the roots. So the vertex will be, the x-coordinate will be halfway between those roots. So whichever way, that's fine. It's only 2 marks, and that's part C. Now for part D, it says find the total distance traveled by p in this interval. Okay, so now I'm gonna bring the graph over. Okay, so now we have to find the total distance traveled by p in the interval from 0 to 20 for this whole interval. So we know that the distance is like the area under the curve. It's the area under the velocity time curve. All right. So from 4 to 20 seconds, we can deal with this just by using our understanding of the areas of basic shapes. Okay, from 0 to 20 seconds. All right, that's 20 over there. Okay, so for this part here, we can use our understanding, as I said, of areas of basic shapes. we can just say the area of this rectangle and the area of this trapezium, and we can find those two areas. Okay, there's two separate shapes you're going to take. So I can take this as the area of A. Let me call this is the area of A and the area of B. Now for the curve part, we've got to use integration to find the area under the curve. But you've got to be careful here, because it says find the total distance traveled, doesn't say the displacement. If it said displacement, I could integrate from 0 to 4, all right, and it will tell me the displacement from the origin, from where it started. Because you see, the velocity here is negative in this whole section here from 0 to 2 seconds. So it's going in the opposite direction from the rest of the journey. So it's like going in the opposite direction, and then it's going in the positive direction. So if we find the displacement, I mean, we're going to have to, basically, we will end up with something different from the distance. The displacement will be this, but the distance will be that plus that. Okay, that distance, which is going to be the area in that section. So when we have something which has a negative velocity, and we have to, in this case, we have to integrate. I need to take the integral of this between 0 and 2 separately. That will give me a negative area, and then between 2 and 4 separately. And then I have to add them together as if they're both positive, right? So that I get the total area. If I just take the integral between 0 and 4, it will give me the area and this area combined, and it will be in a positive area, negative area. They'll subtract these areas, and you won't get the distance, you'll get the displacement. Okay, so for A and B, no problem. A is basically going to be a rectangle, and this is 10 against 40. 10 times 40, that's 400. Okay, so that's 400 meters. And the area of B is a trapezium. The distance between their parallel sides, which is 20 minus 14, which is 6, over 2 times the sum of the parallel sides, which is 40 plus, that was 28. 40 plus 28. So that gives me 3 times 68, which is 180 plus 24, 204 meters. That's the area of B. Okay, so we've got this total area and this total area. And now we've got to find the area under the curve. Okay, now for the area of this section C and D here. Okay, we need to find that area. This is going to be found by integration, but we must take care of the fact that C is below the horizontal axis, the time axis. So this means there's negative velocity, which if we just take the integral between 0 and 4, okay, of 5t squared minus 10t with respect to t, it's going to give us the displacement, okay, which will be the net kind of, of the area between these two. Okay, so it's going to take this as a negative area, this is a positive area, and it'll be added them together. It won't give us the distance, it'll give us the displacement. It's like the object say this is the origin. It's like it started going in this direction, and then it started going that direction. So the displacement will give us this distance between where it started and where it ended up. That's the displacement. But they're asking here for us to find the distance. So the distance is going to be this distance is traveled plus that distance is traveled. So we need to find this area here and this area here and add them together as positive areas. Okay, if we leave it like this, it's going to give us the area, this part negative, this part positive, and it'll give us just the displacement. So I have to split this into two parts. Okay, I have to split this into the part where I'm finding from 0 to 2, okay, and then I've got to change its sign, and I've got to add the area between 2 and 4, okay, of the same integral, 5t squared minus 10t with respect to t, and wherever this comes out of, I've got to change its sign. I've got to change its sign for this part, and that will give me the distance traveled. Okay, so let me first just integrate this expression without the limits, and then I'll use the integrated version to then, so if you integrate this without the limits, you end up with 5t cubed over 3, 5t cubed over 3 minus 10t squared over 2, add 1 to the power, divide by the new power. That's going to give me 5t squared. Okay, and I'll just put plus c for now. But now when I use my limits, I'm going to use my limits for the first part. I have 5t squared minus 10t between the limits of 0 and 2. Now, what you can do to make this become positive is you can switch them and put 0 and 2 like this. Instead of the lower one underneath and the upper one on top, it will switch the limits and give you a positive. It will give you a positive area instead of a negative area. So you can do that, that's fine. Right? You could either find it will be negative and then you can switch the sign, or you can do this, it will automatically switch the sign, and that will be fine. And then I've got to add to that the area between 4 and 2, so I'm going to have 5t squared minus, 5t, what am I doing? The integrated version, sorry about that. This is 5t cubed over 3 minus 5t squared, and this is 5t cubed over 3 minus 5t squared, but this is now between 2 and 4. Okay, so we find what these are. So of course you put 0 into here, you're going to get 0, minus, you put 2 in here, you're going to have 5 times 8, which is 40. That's 40 over 3, okay, and minus 5 times 2 squared, which is 5 times 4, which is 20. Okay, so that's going to give you that. Okay, and you're going to have plus, and now we're going to put 2 into here. When we put 2 into here, we're going to have the same thing as this is going to be 40 over 3 minus 5 times 4, which is 20. And you're going to have minus, in fact, first we put 4 into there, not 2, sorry. Put 2 into there first, and then you put 4 into there first, and then 2. So 5 times 4 cubed, which is 64 over 3 minus 5 times 16. And you take away from that what you get when you put 2 in here, which is the same as this, would be 40 over 3 minus 20. So that should give you your area. So when we have 40 over 3, so we're going to have minus, put in brackets, 40 over 3, and take away 20, and plus, we're going to have another bracket, you have 5 times 64 over 3 minus 5 times 16. Okay, and you're going to take away from that, again, 40 over 3 minus 20, another bracket, and that gives us 40. So that's going to be 40 meters altogether. So therefore, we end up with the total area. Total area is the area of these. There's 400 plus 204. So 400 plus 204 plus 40, that's 644 meters. 644 meters is the total area that this object has traveled in those 20 seconds. Okay, so that's the answer to part D. Just be careful about these negative sections, that's all. Take them separately as we did here, between 0 and 2 and between 4 and 2. And to make this become positive, you can switch the limits. That will become positive, as we can see. It would have normally been this minus 0, and this gives you a negative value, but 0 minus that gives you a positive value. Okay, so there's the answer to question number, what was it, number 6? Number 6 from this specimen paper of Cambridge Mechanics M1 9709. Other questions from this particular paper is found in the playlist, which has a link at the end of the video over here. Other questions from this topic of kinematics and variable acceleration can be found in the playlist over here. You can subscribe to my channel by clicking on this link, and you can watch a video by clicking on the link at the top here, which tells you how to use my channel efficiently. Thank you for watching, and see you soon.